There is an ancient proverb that says, it's very difficult to find a black cat in a dark room, especially when there is no cat. I find this a particularly apt description of science and how science works. Bumbling around in a dark room, bumping into things, trying to figure out what shape this might be, what that might be. There are reports of a cat somewhere around. They may not be reliable, they may be, and so forth and so on. Now, I know this is different than the way most people think about science. Science, we generally are told, is a very well-ordered mechanism for understanding the world, for gaining facts, for gaining data, that it's rule-based, that scientists use this thing called the scientific method, and we've been doing this for 14 generations or so now. And the scientific method is a set of rules for getting hard, cold facts out of the data. I'd like to tell you that's not the case. So there's the scientific method, but what's really going on is this. And it's going on kind of like that. So what is the difference, then, between the way I believe science is pursued and the way it seems to be perceived? So when I go to a meeting, after the meeting day is over and we collect it with my colleagues, we never talk about what we know. We talk about what we don't know. We talk about what still has to get done, what's so critical to get done in the lab. Indeed, this was, I think, best said by Marie Curie, who said that one never notices what has been done, but only what remains to be done. This was in a letter to her brother after obtaining her second graduate degree, I should say. Nonetheless, this is what I think we were leaving out of our courses and leaving out of the interaction that we have with the public as scientists, the what remains to be done. This is the stuff that's exhilarating and interesting. It is, if you will, the ignorance. That's what was meant. I use this word ignorance, of course, to be at least in part intentionally provocative, because ignorance has a lot of bad connotations, and I clearly don't mean any of those. So I don't mean stupidity. I don't mean a callow indifference to fact or reason or data. The ignorant are clearly unenlightened, unaware, uninformed, and present company today, except that often occupy elected offices, it seems to me. That's another story, perhaps. I mean a different kind of ignorance. I mean a kind of ignorance that's less pejorative, the kind of ignorance that comes from a communal gap in our knowledge, something that's just not there to be known or isn't known well enough yet or we can't make predictions from. The kind of ignorance that's maybe best summed up in a statement by James Clerk Maxwell, perhaps the greatest physicist between Newton and Einstein, who said, "Thoroughly conscious ignorance is the prelude to every real advance in science." I think it's a wonderful idea, thoroughly conscious ignorance.
All right, so first off, we stop for thoroughly. Thoroughly is just a word that means completely or like all the time. Conscious, think about being conscious or unconscious, right? So like if you're sleeping would be unconscious, and conscious is just knowing, right? So to be conscious of something is to know about it. And then ignorance is just not knowing something, right? Talking about just not really knowing what's happening. And prelude is another big word in here, and that word just means before. All right, that prefix pre, like in preview. So what this means altogether is all the time, knowing what you don't know comes before every real advance in science. So what it's saying is that knowing what you don't know, that's asking questions. You only can ask questions about things that you don't know about and you're aware of. And that science and every real advance, everything we know about the universe comes because somebody knew they didn't know something, and so they ask a question, right? And that is what this quote is really trying to get to.
So that's the kind of ignorance that I want to talk about today. But of course, the first thing we have to clear up is what are we going to do with all those facts? So it is true that science piles up at an alarming rate. We all have this sense that science is this mountain of facts, this accumulation model of science, as many have called it. And it seems impregnable. It seems impossible. How can you ever know all of this? And indeed, the facts are important. You have to know a lot of stuff to be a scientist. That's true. But knowing a lot of stuff doesn't make you a scientist. You need to know a lot of stuff to be a lawyer or an accountant or an electrician or a carpenter. But in science, knowing a lot of stuff is not the point. Knowing a lot of stuff is there to help you get to more ignorance. So knowledge is a big subject, but I would say ignorance is a bigger one. So this leads us to maybe think about a little bit about some of the models of science that we tend to use, and I'd like to disabuse you of some of them. So one of them, a popular one, is that scientists are patiently putting the pieces of a puzzle together to reveal some grand scheme or another. This is clearly not true. For one, with puzzles, the manufacturer has guaranteed that there's a solution. We don't have any such guarantee. Indeed. So I think the puzzle model doesn't work. Another popular model is that science is busy unraveling things the way you unravel the peels of an onion. So peel by peel, you take away the layers of the onion to get at some fundamental kernel of truth. I don't think that's the way it kind of works either. Another one, a kind of popular one, is the iceberg idea, that we only see the tip of the iceberg, but underneath is where most of the iceberg is hidden. But all of these models are based on the idea of a large body of facts that we can somehow or another get completed. We can chip away at this iceberg and figure out what it is, or we could just wait for it to melt, I suppose, these days. But one way or another, we could get to the whole iceberg, right? Or make it manageable. But I don't think that's the case. I think what really happens in science is a model more like the magic well, where no matter how many buckets you take out, there's always another bucket of water to be had, or my particularly favorite one, with the effect and everything, the ripples on a pond. So if you think of knowledge being this ever-expanding ripple on a pond, the important thing to realize is that our ignorance, the circumference of this knowledge, also grows with knowledge. So that knowledge generates ignorance. This is really well said, I thought, by George Bernard Shaw. This is actually part of a toast that he delivered to celebrate Einstein at a dinner celebrating Einstein's work, in which he claims that science just creates more questions than it answers. I find that kind of glorious. So I'd say the model we want to take is not that we start out kind of ignorant and we get some facts together and then we gain knowledge. It's rather kind of the other way around, really. What do we use this knowledge for? What are we using this collection of facts for? We're using it to make better ignorance, to come up with, if you will, higher quality ignorance. So yes, you do need to know a lot of stuff as a scientist, but the purpose of knowing a lot of stuff is not just to know a lot of stuff. That just makes you a geek, right? Knowing a lot of stuff, the purpose is to be able to ask lots of questions, to be able to frame thoughtful, interesting questions, because that's where the real work is. I'll give you an example from my own lab, my own particularly smelly questions, since we work on the sense of smell. But here's a diagram of 5 molecules in sort of a chemical notation. These are just plain old molecules. But if you snip those molecules up these 2 little holes in the front of your face, you will have in your mind the distinct impression of a rose. If there's a real rose there, those molecules will be the ones. But even if there's no rose there, you'll have a memory of a molecule. How do we turn molecules into perceptions? What's the process by which that could happen? Here's another example. 2 very simple molecules, again in this kind of chemical notation. Might be easier to visualize than this way. So the gray circles are carbon atoms, the white ones are hydrogen atoms, and the red ones are oxygen atoms. Now, these 2 molecules differ by only 1 carbon atom and 2 little hydrogen atoms that ride along with it. And yet one of them, heptyl acetate, has the distinct odor of a pear. And hexyl acetate is unmistakably banana. So there are 2 really interesting questions here, it seems to me. One is, how can a simple little molecule like that create a perception in your brain that's so clear as a pear or a banana? And secondly, how tell the difference between 2 molecules that differ by a single carbon atom? I mean, that's remarkable to me. Clearly the best chemical detector on the face of the planet. You don't even think about it, do you? This is a favorite quote of mine that takes us back to the ignorance and the idea of questions. I like to quote because I think dead people shouldn't be excluded from the conversation. And I also think it's important to realize that the conversation's been going on for a while, by the way. So let me end with a quote from William Butler Yeats, who said, "Education is not about filling buckets, it's lighting fires." So I'd say, let's get out the matches. Thank you.